Hey guys, welcome back to Statistics Explained. In this video, we will solve some question based on PDF and CDF. So here I have one question which says X and Y has a joint PDF and the PDF is given to us. Then it is asking us to find out the range and then the constant C. Then we have to go with the marginal PDFs and then we have to find the probability of Y which is less than 2x square. So let's begin working here. So I have been given some data here which says x is greater than equal to 0. Also it says y is greater than equal to 0. In this case also I have x plus y less than 1. Now the thing is, we know that your PDF cannot be negative and it's 0 otherwise. So it is a function which is valid PDF. Now what we have to do is we have to find out the range. So in this case I can say x will range from 0 to 1, and in this case your x will be at least less than 1 because I have x plus 1 less than 1 also. In another case I can also say for a given range of x and y we will have this range from 0 to 1 minus x. Why? Because I have been given x plus y less than 1, which means I can write it down like this: y should be 1 minus x. Here we are given this, so that is why I can say x and y will range between 0 to 1 minus x. Now if I just think of it, this will be a triangular region on x and y verticals, because x and y can be either 0 and 0, or it could be your x and y is where x is equals to 1 and y is 0, or another case could be where your y is 1 and your x turn out to be 0. So if you just plot this, you will have one point here, one will be here and one will be here. This will be the triangular region of this joint PDF, and this will be the range also. So we are done with the part 1. Let's move to next part, and in the next part we have to find out what will be the value of constant C. So in this case I have to do integration, and we know that since we have a PDF here, the function will be equals to 1 always. So if I just have to write down the range of x, I can say it will be 0 to 1, and the range of y will be 0 1 minus x. This we just calculated here, so I am using this only, and later on I have to write down the function. So the function given to us is cx plus 1, and we have dy by dx, and this is equals to 1. Now we have to solve this, and we have to do integration part here. So if I just solve this, I will have 0 1, and this is cx plus 1. Rest, when I have to do integration part here, can write dx also here, and then I have to write y. Since it will be 1, I have to do integration for dy, and this whole will be equals to 1. So I'll move further and I'll write cx plus 1 here, and I will have 1 minus x equal 1. Now if I just multiply this, I'll have cx plus 1 minus cx square and minus x here. This will be equals to 1. Now I just, there would be dx also and a dx also here. Now I'll just integrate this, so I'll have cx square by 2 plus x minus cx3 by 3 minus x square by 2, and this whole will have a range of 0 to 1, which will be equals to 1. Now if I substitute the value, it will be 1 by 2 plus 1 minus 1 by 3 minus 1 by 2 equal 1. And if I'll just take the part here, it is c here and it is c here also. So now it will be 3c plus 6 minus 2c minus 3 equal 6. So if you solve this, you'll have 6 minus 6 equals 0, and then you'll have c equal to 3. So the value of c will be 3 in this case, and this is how you solve this up. So now we have to do the other part, and here we have to find the marginal PDF of x, and also we have to find the marginal PDF of y. So I can write this as marginal PDF of x, and here I have to write down the function, which is 0 to 1 minus x. We already calculated the range here, and then I have to write down the function. We have calculated c is equals to 3, so I am using that here, and I'll just write dy here. Now we'll solve it. So when I solve this, I can write this as 3x plus 1, and here I can write the value of my function, and for this I'll have a range 0 to 1 minus x. Now I can say this will be 3x plus 1 minus x. So if you solve this up, you'll have 3x plus 1 minus x minus 3x square. So we have minus 3x square, then plus 2x and plus 1. Similarly, we can solve it for y, and for y we have the range equals to 0, 1 minus y. Here I'll write 3x plus 1, and we have dx here. So now when I solve this, we'll have 3x square by 2 plus x, and then the range, which is 0 to 1 minus y. So I can write 3, and I can write 1 minus y square here by 2 plus 1 minus y. So this will be the solution for this part. Let's move to next, and for this we again, all right. So in the next part, we have been given that we have to find out py is less than 2x square. In order to solve this, we have to split the range, because I know that x can vary from 1 to minus y. So what we will do is we will simplify this. So just in case, assume x belongs to 0 to half, then in this case this line will actually be less than 1 minus x. So the upper limit in this case will be y equal 2x square. Similarly, if I'll say x belongs to 1 by 2 to 1, in this case we will have 1 minus x line will not be crossing this. So in this case I can say that my I can say my upper limit will be y equals to 1 minus x. So what I have is two limits. One in the case when we have x ranging from 0 to 1 by 2, and another in the case when I have x range from 1 by 2 to y. So we will make the function now. The first integral in this case will be 0 to 1 by 2, and we will also have 0 to 2x square, and then we will write down the function we had, that is 3x plus 1 dy dx. So we'll start solving this, and we will have 0 to 1 by 2, 3x plus 1. Here will be dx, and then for y I will have my limits. So we'll write it like this. So now when I solve this, I can say it is 0 to 1 by 2. Here I will have 6x cube plus 2x square, and then I will have 6x by 4 plus 2x cube by 3, and we can say this is 3 by 2 into 1 by 2 raised to power 4 plus 2 by 3 and 1 by 2 raised to power 3. So I'll have 3 by 2 into 1, and here I will have 16 plus 2 by 3, and here I will have 1 by 8. So I will have 3 by 32 here and 1 by 12 here. So if I take LCM and solve this, you will get 17 by 96. Alright, let's do the other part here. So I will write down the next integral equation, which will be from 1 by 2 to 1, and here it will going from 0 to 1 minus x. In this case again I will have my 3x plus 1 and dy by dx. We will solve this, so I'll have 1 by 2, 1 here, and 3x plus 1 dx, and then here I will have y, which will have a range 0 to 1 minus x. So I can say this goes to 1 by 2, 1, 3x plus 1, 1 minus x, and then I can write this as 1 by 2, 1, 3x plus 1 minus 3x square minus x, which will be 1 by 2, 1, and 2x plus 1 minus 3x square. I can then write it like this: 2x square by 2 plus x minus 3x 3 by 3, and the range goes from 1 by 2 to 1. So moving on further, I will have here your x square plus x minus x cube 1 by 2 to 1. So now I can write this as 1 plus 1 minus 1 minus, and here I will have 1 by 4 plus 1 by 2 minus 1 by 8. So I can say this will be your 8 minus 2 minus 4 plus 1 by 8. This all will be equals to your 3 by 8. So I have my here 3 by 8, and I also have above your 17 by 96. So I can add these two, and once I'll add this, I'll have the answer. So if I add 3 by 8 plus 17 by 96, then I can take the LCM, and the answer will be 53 by 96. So here I can say this is 53 by 96. Alright. So coming to the next problem, what we have here is a jointly continuous random variable with the joint PDF function given to us, and we have to verify whether x and y are independent. So in order to find out if x and y are independent or not, I have to calculate the marginal PDF of x, then marginal PDF of y, and then we'll multiply it in order to find out whether the function fxy xy is equals to fxx or fyy. So let me show you the working of this. So I will first find out the marginal PDF for x. So I can write it like this, and here I have also been given that x and y are greater than equal to 0. So in this case I will have my limit from 0 to infinity, and I'll just write down the function. So I'll have 2x plus 3y here, and now I'll just write here dy. So I can write this as 6 e to the power minus 2x, and 0 to infinity I can take here, and then I can write e to the power minus 3y by dy. Then I can write 6 e to the power minus 2x, and here if I integrate this it will be e to the power minus 3y, and here I'll have 3, then I can say 0 to infinity. So I can write this as 6 e to the power minus 2x, and when I substitute this value, one will be 0 and this will be plus e to the power minus 3y will be 1 by 3. So I can say this will be 2 e to the power minus 2x. Alright. Next what I have to do, I have to find the marginal PDF for y. So I can write down the similar function here, and I can write 0 to infinity 6 e raised to power minus 2x plus 3y. This is in bracket, and I have here dx. So next what I can do is I can write 6 e to the power minus 3y outside, and I'll write 0 to infinity. Here I will have e raised to power minus 2x by dx. So I can write this 6 e to the power minus 3y, and this will be your function. So I'll once integrate this, this will come out to be this, and I have the range 0 to infinity. So I can write 6 e to the power 3y, and when e power minus it is 0, and this will be 1 by 2. So I can say this will be 3 e to the power minus 3y. Alright. Now what next is I have to actually multiply these two. So I'll just write down fxx and fyy. This should equals to fxy xy in order to find out if they are actually independent or dependent. So if this equals, it is independent, otherwise they will be dependent. So I can write 2 e to the power minus 2x here, and 3 e to the power minus 3y. So if I multiply this, it is 6, and I can write 2x plus 3y, and I can put this in bracket. So if you see here, I have this function, and this is similar to this function, and we have range from x 0 to infinity and y 0 to infinity, which is given in the function also. So I can say x and y are independent. Yes, they are. All right, let's move to next part and solve that one. So in this part we have to find out the conditional expectation which is given to us. So I can write it is expectation of y given x greater than 2. This can be written as integral 2 to infinity for x, because x is given to be greater than 2, and for y it will 0 to infinity. Now for the function, it is always y fxy, and here I will have x comma y dy by dx, which is the formula for conditional, and here I will have p x greater than 2, because I have an expectation that x should be always greater than 2 given the condition. So let's find out p x greater than 2 first. So in order to do this, we will have 2 to infinity, and now I will write down the function. So it will be 2e raised to power 2x dx, which we just calculated in the above part for the marginal. So if I integrate this, I will have e to the power minus 2x minus 2 to infinity will be my range. This is a sign of minus. Then if I substitute this, e to the power infinity will be this minus, and this is e minus 4. This should be plus. So e to the power minus 4 is the answer for this one. Now that we know that probability x greater than 2 is e minus 4, we have to work on the part of the numerator. So if I just write that down, it's 2 to the power infinity, and here we will have fx by x dx, and then we will also have 0 to y in phi multiplied by fy y and dy here. So we have already calculated this one, and this has turned out to be e to the power minus 4, which we have here, and we need to solve this one now. So I'll just write 0 to y and multiply by y, e to the power minus 3y dy. E to the power minus 3y is coming from the marginal probability we just calculated above in the part 1. So next what will happen, I'll just integrate this. This is 3 e to the power 3y. Next what will we do is we will just calculate this. So I'll just write down that. So I can say this will be 3, and here I can just use the rest of the part. So I'll write 3y dy. So if we just solve this, we will have 3 here, then this will come out to be y by 3 minus e to the power minus 3y, and here we will have 0 to infinity. So if I just substitute this, then we will have here we will have 0, and then we will also have here minus 1 by 3 as this. So if we solve this, we have 1 here. So now we have our numerator as e to the power minus 4 into 1, and our denominator as e to the power minus 4, and this is for y x greater than 2. So in this case we will have solution as 1. So I can say y by ex equals to 1. Alright, so let's do the third part now. In this part we have to calculate probability x greater than y. So if I write it down, it will be 0 to infinity and y to infinity, because we have been said that x is greater than y, and then we will have our function which will be fxy xy and dy by dx. So let us solve this. So now if I write it down, it is 0 to infinity, y to infinity, and here we will have 6 e to the power minus 2x plus 3y dy by dx. So let us do one thing here. Let us integrate with respect to x first. So if I integrate with respect to x, we will have here 6e to the power minus 3y and e to the power minus 2x dy by dx, with the y ranging from y to infinity. Alright, so moving on further, we will have 0 to infinity here, 6 e to the power minus 3y, and here I will have e to the power minus 2x minus 2, and the limits which will be y to infinity dx. So I can write 0 to infinity 6 e to the power minus 3y, and now because I have here minus, so this will be 0 and this will be 2 e to the power minus 2y. So this can be further written as 0 to infinity and 3 e to the power minus 3y and e to the power minus 2y, which can be further written as 0 to infinity 3 e to the power minus 5y. And if I integrate this, I will have 6e minus 5y by 5, and there would be a sign of minus, and I can write 0 to infinity. So this will turn out to be 3 e to the power infinity minus infinity is 0, and I will have here minus, and also I will have here 1 by 5. So if I solve this, I'll have 3 by 5, which is the answer for finding probability x by 5. So it's 3 by 5. Alright. So this is how actually you solve this problem. Let us move to the next one. Alright, so in this problem we have been given that x has the PDF function which is 2x ranging from 0 to 1, and we have x equals to x being uniformly distributed for y on the interval minus x to x. So in this case I can say the conditional PDF of y given x equals to x is, I can write f y and x as the PDF part. This should be like this, and I can say this will be 1 by 2x for minus x less than equals to y less than equals to x. This is because y is uniformly distributed over minus x to x as given in the question, and the length of the interval will be 2x in this case. So we can say the uniform PDF height will be half, which is 1 by 2x. So I can say the joint PDF for fxy will be given as like this: fx comma y, and here I will have x comma y, then we will have fx x and fy given x, y given x. So if we solve this, then we will have what exactly will be the joint PDF. So I can actually substitute here the value given to x, which is 2x. So I can write 2x, and we just found this will be for y ranging between minus x to x for a uniform distribution. So I can write here 1 by 2x, and if I solve this, this will be coming out to be 1, and this will be for 0 to x less than 1 and y ranging from minus x to x. So I can write down the joint PDF now, and the joint PDF will be written as always like this: 1 for 0 to x less than 1 and minus x less than y less than x, and it will be 0 otherwise, because it cannot be negative. So this will be the range for the joint PDF in this case. Let's move further and find out the marginal PDF for y. So we come here, and to find marginal PDF of y, we have to integrate the joint PDF for all values of y that correspond to each y. Since y is supported on the interval minus 1 to 1, the limits of integration will depend on it. So what we will do is we will write down the marginal PDF of y function. So it will be f y and here we will have y. Then I will write here the limit, so it will be this, and I can write y like this, which is the integral part. This is because the value of x must satisfy this. X should be greater than or equal to y modulus, because the range is minus x to x for y. So the limits of x can range from modulus of y to 1. That is why we have written like this. Now I can write f xy, and here we will write xy dx. Since my fxy is equals to 1, we can write down here, and this we calculated above. So I can write here modulus of y 1, and this will be 1, and I can write here dx. So if I solve this, we will have here x 1 modulus of y. So I will have 1 minus modulus of y. Now using this, I can write down the marginal PDF of y. So I will write it here fy y, and this will go like this. I will have here 1 minus modulus of y for y ranging from minus 1 to y to 1, and also for another part I will write 0 otherwise, because that cannot be arranged. So this will come out to be the marginal PDF of y. In this part, we have to find out the probability that modulus of y will be less than x cube. This is the same thing as finding probability of y modulus less than x cube equals to 0 to 1 integration of probability y less than x cube, given that x is equals to x. So I'll just write down that. So we will have p, and here we will have modulus of y less than x cube. This can be 0 to 1 integration, which is given in the problem, and probability y less than x cube for x is equals to x fx x dx. Now see this. For a given value of x, modulus of y must lie between minus x to x, as mentioned in the problem. And we are looking right now for the probability that y should be less than x cube. Since y is uniformly distributed over minus x to x, which is given in the problem, the probability of y that is less than x cube is the ratio of interval minus x cube to x cube and to minus x to x. So I can write this as, so we can write this as p modulus of y less than x cube given x equals to x as 2x cube by 2x. So this will come out to be x cube by x and then x square. Now we can integrate this over x from 0 to 1. So I can say probability y modulus less than x cube will come out to be 0 to 1 x square, and I can actually add my function here. So I can say this will be 2x dx. Solving this, I can say 2 will come out 0 to 1, and I will have x cube here dx, which will come out to be 2x 4 by 4 1 0, and this will be 2 1 by 4, so it will be half. All right, so yeah, that is for this problem. Let us move to the next one. All right, so in this problem we have been given a joint PDF, and we have to show rxy in the xy plane. So rxy in the xy plane will depend on what exactly the range is. Here I have x ranging from 0 to 1, and then I have y ranging from 0 to square root of x. So in this case, what will happen? The region for rxy will be bounded by the function, and that curve will be y equals to square root of x. So the graph for y equal to square root of x actually define the reason for this plane. Alright, let's move to the next one then. We have to find out fxx and fyy. That is basically finding out the marginal probability. So in order to find out what exactly will be the marginal PDF of x, we will write down the function. So we will have x, and here I will have 0 to square root of x, the range. Then I will have 6xy, and we will write here dy. Now in order to solve this, we will write fx x, and we will take 6x outside. So we will have 0 square root of x and y dy inside, which will come out to be 0, and here we will have y square by 2, 0 square root of x. So we will have 6x by 2, and here we will have x. So we can write this as 3 of x square. So I can say this will be the marginal PDF of x for range 0 to x less than 1. Similarly, we can find out the marginal PDF for y. So we will write down here the function. We will have y square here and then 1. Why y square I am writing? Because this is what exactly the integration of the joint PDF will go all over. Next, what we write is the function. So I will write down the function, and now we will have 6y here, and this will again y square to 1 x dx. So we have 6y x square by 2 ranging from y square to 1. So this will be 6y 1 by 2 minus, again we will have y square 2 by 2. So this will come out to be 6y by 2, and we will have here y minus y to the power 4. So this will be 3y minus 3y to the power 5. So we can say this will be the marginal PDF of y ranging from y 0 to 1. Alright, let us move to the next one. Alright, so next we have to see whether x and y are independent or not. So in order to see this, we have to multiply f x x and f y y. So we already calculated this above. This was 3x square, and this was 3y minus 3y to the power 5, which will not be equals to 6xy. So we can say they are not independent. Alright. And the next one says we have to find out the conditional PDF of x given y. So I can write down this as f x by y, and here we will have x by y, which is the function xy upon f y y. So this we have already calculated above, which is 3y minus 3y to the power 5, and this is the original function we have. So if you solve this, you will get 2x 1 minus y to the power 4, which will be the conditional PDF for the range of y, which is y square to x less than 1. And why y square is coming? Because we have here y ranging from 0 to x square root, which we can always convert and get through this. All right, so we have solved this one. Let's move to the next one now. So in this part we have to find out the conditional expectation of x given a specific value of y. So we can write down the formula here. We'll write e here x y equals y, and now I will write down the range. So I can say it will go from y square to 1, which is the upper limit, and then I can write x f x by y xy dx. We calculated just above the value for this one, so I can substitute that value here. I can write y square by 1, x will be multiplied by 2x, 1 minus y to the power 4, and I can write here dx. So now what I can do is I can take 2 1 minus y to the power 4 outside, and I can write y square to 1. This will be x square dx. Now we have to solve this. So this will come out to be 2 1 minus y by 4, and this will be x3 by 3 1 by y square, which can be further written as 2 1 minus y by 4 multiplied by 1 by 3 minus 1 minus y by 6 upon 3. Alright, so we can say this will be 2 1 minus y to the power 6, and this will be 3 1 minus y to the power 4. So this will be the answer for the conditional expectation. Alright, let us move for the next one. So in this case now we have to find out the variance. So in order to find out the variance, I can actually write variance x for a specific value of y, the expectation, so e x square for y equals to y, and minus expectation x by y for a specific value of y for square. Alright, so what exactly is the thing? We have already calculated this once we calculated our expectation. So what is left is this one. So I will write down the formula for calculating e x square for a specific value of y. This will be ranging from y square to 1 for x square f x by y for x comma y dy here. So once we have this, we can write down the function as 2 1 minus y to the power 4 going from y squared to 1 x cube dx. So now that we have this, we can solve it up. So I can write 2 1 minus y to the power 4, and here I can write x to the power 4 by 4 ranging from 1 to y square. So this can be written as 2 1 minus y to the power 4 and 1 by 4 minus y to the power 8 by 4. This will come out to be 2 1 minus y to the power 8 4 1 minus y to the power 4. Further, this can be simplified as 1 by 2 1 minus y to the power 8 and 1 minus y to the power 4. Now this value can be substituted into this function, and this value can be taken from the last one which we solved, which will give us the variance for xy. Alright, so that is what exactly the crux of it, and that is how exactly you solve this kind of problems. Alright, so I think that is all for this video. We have solved 4 problems on PDF and CDF of advanced level. If you like this video, please subscribe to our channel, give us a thumbs up and share it with your friends. I'll see you in the next one. Thank you.